Hello. Okay, so let's look at this problem. We collected hydrogen gas underwater, and we found that we collected 2.58 liters at 25 degrees Celsius, and the atmospheric pressure was 98.6 kPa. From the table, I found that the pressure of water at 20 degrees Celsius of water vapor is 17.54 millimeters of mercury. So I want to find what is the pressure of just the hydrogen in the container. So what I need to do is convert these pressures to the same unit. I don't really care which one. I'm going to convert my kPa to millimeters of mercury. So I'm going to go ahead and take this and divide by 101.3 and times by 760. I'm going to put that in my calculator. And I get out here, it was 739.7 millimeters of mercury. So now I want to find the pressure of just the hydrogen gas. So I'm going to take P total equals the pressure of hydrogen gas plus the pressure of the water. So the total pressure is what we just found here, the atmospheric pressure. So I have 739.7 millimeters of mercury equals the pressure of hydrogen gas plus 17.54 millimeters of mercury. So to find the pressure of hydrogen, I'm just going to be subtracting the 17.54. So I'm going to put it in my calculator. For sig figs, because I'm subtracting, I'm going to round to one decimal place. So in my calculator, I got 722.16. I'm going to record my pressure of hydrogen is 722.2 millimeters of mercury. So now the second part of this asks, find the volume of hydrogen gas at STP. So we're going to actually use the combined gas law here. So I have that my initial pressure of the gas is what I just calculated. My initial volume is that 2.58 from the problem, and my initial temperature is the 20 degrees Celsius. My final pressure, P2, is 1 atmosphere, which is 760 millimeters of mercury. We're looking for our new volume, and my final temperature is 0 degrees Celsius, because remember, ATP or STP is 1 atmosphere and 0 degrees Celsius. So next I already changed this to millimeters of mercury, so they're the same, but I need to get temperature into Kelvin. So I'm going to add 273.15. This is going to be 293 Kelvin, and this is going to be 273 Kelvin when I add it. All right, and then I'm going to plug this into the combined gas law equation. So I'm going to say, okay, so I have 722.2 times 2.58 divided by 293 equals 760 times x over 273. And then I'm going to put this all in my calculator to solve. I'm going to do 722.2 times 2.58 times 273 divided by, and then I'm putting in parentheses 298 times 760 and parentheses, and I get out 2.28 liters. Okay, so first I use Dalton's law of partial pressure to find the pressure of just the hydrogen, and then I use the combined gas law to get to the volume at STP.